Hello everyone and welcome back to the last question we'll attempt together for Paper 2 Variant 2 Physics AS level for the May-June 2023 series. Now, so far we have thoroughly discussed all of questions 1 up to 7. So, before we dive into this last question, I highly encourage you to check the rest out. We even have a separate playlist for that, so that'll be easier for you to go through. So do that first before we dive in here. And if you're already covered that, then good job so far. And let's wrap up with the following question. Now part A says, the nucleus P and nucleus Q are isotopes of the same element. Nucleus Q is unstable and emits a beta minus particle to form nucleus R. Now part I says that for nuclei P and Q, compare the number of protons and then the number of neutrons. Now this is where we have to remind ourselves of what isotopes are. That isotopes are basically atoms of the same element with the same number of protons but different number of neutrons. So by definition, we already know what the answers are to both of these parts. The number of protons have to be the same while the number of neutrons have to be different. Alright, next part. When nucleus Q decays to form nucleus R, the quark composition of a nucleon changes. State the change to the quark composition of the nucleon. Now, we're told here that nucleus Q is the one that's emitting a beta minus particle to form a new nucleus R. Here we remind ourselves that when it comes to beta minus decay, that's basically a high-speed electron leaving a nucleus, right? So if let's say our nucleus Q has a proton number Z and a mass number A, when emitting an electron, that high-speed electron which is our beta minus particle, it has a negative charge and no contribution to the mass number, right? So for this new nucleus R, it's going to be the proton number that increases by 1, while the mass number stays the same. And the reason that happens is because within the nucleus, it's a neutron that is turning into a proton, right? But here they're asking for how the quark composition is changing. So here we have to remind ourselves of what a neutron contains and then what a proton contains. A neutron, if you remember, contains 2 down quarks and 1 up quark, whereas the proton contains 1 down quark and 2 up quarks, right? So what we see here clearly is that a down quark is turning into an up quark. And so that's precisely what we'll write here. That when Q decays to form R, it's the up quark that changes, or sorry, I'd rather say it's the down quark that is changing or changes to an up quark. Right? Now comes part 3. State the name of another particle that must be emitted from nucleus Q in addition to the beta minus particle. And this is where we recall that the other particle that needs to be emitted is what we call an antineutrino. It doesn't really contain, or rather it doesn't really create any changes in the nuclear composition because it in itself has no charge and has negligible mass. It's only there because it was experimentally found out to be emitted during the beta minus decay process, and moreover it was necessary for the momentum to be conserved during this process of decay. So the particle that needs to be emitted is the antineutrino, right? Finally, we have part B. A hadron consists of 2 charm quarks and 1 up quark. Determine in terms of the elementary charge E, the charge of the hadron. Now this hadron, let's call it capital H, contains 2 charm quarks and 1 bottom quark. Here we'll remind ourselves of the fact that 1 charm quark has a charge of plus 2 over 3e. It is a fractional charge. Much in the same way, 1 bottom charge, or 1 bottom quark rather, has a charge of minus 1 over 3e. So it's just a matter of adding these up in accordance with the composition of this hadron, which in our case would be plus 2 over 3 plus 2 over 3 plus minus 1 over 3 times the elementary charge. In which case we just add up the numerators, 2 plus 2 minus 1 over 3 times the elementary charge. 4 minus 1 will give us 3. We get plus E, or just plus 1 times the elementary charge, right? Alright, Great job! We have covered the entire paper for May-June 2023, Paper 2, Variant 2 for Physics AS level. We hope that these series of videos that we have uploaded so far has helped you understand how to not only revise the concepts while attempting a question, but also you might have picked up on a few tips as to how you can attempt such questions, even if you know the theory. So, we hope this helps, and next time we will dive into more past paper questions. Alright? So, take care and have a good day.